Earlier when we talked about complex numbers, we talked about how we could add, subtract, and multiply them, but we did not talk about dividing them. Now we're ready to talk about how we divide complex numbers. And the way we divide complex numbers is we clear the I in the denominator by either multiplying by I and we multiply by I if we have a monomial, or just one thing in the denominator, or by multiplying by the conjugate of the denominator. And we do that if we have a binomial, if we have a plus bi. Speaking of which, if I've got a plus bi, if I went to multiply by its conjugate, that would be a minus bi, changing the sign in the middle. And what we know about multiplying conjugates is we just have to square the first term and square the last term with a minus in between, which is going to give us minus b squared I squared. But the I squared is -1. And so if I make that -1, that's going to change the sign. So we end up with just the square of the first number plus the square of the second number. That's going to help us shortcut our way to our solutions. Let's take a look at doing some division with complex numbers. What if I have 3 plus I, and I want to divide it by 4i? Well, because this is a monomial with just one term in the denominator, just the 4i, I'm going to multiply top and bottom by I. And that's going to allow me to distribute through in the numerator, giving me 3i plus I squared. Remember, I squared is -1. Over 4 times I is 4i squared, which gives us -4, because that I squared is -1. Now, generally, we like to express our solution as a real number plus an imaginary number. In other words, we don't want this to be a fraction. We're going to go ahead and distribute this divide by 4 onto both parts. And when I do, doing the real part first, the part without the imaginary, that's going to come first. -1 divided by -4 is a positive 1/4. Then when I do the 3i divided by -4, I get -3/4 times I. And this is the proper form of our complex solution. Let's try a second example. Let's take 4i and put it over to -5i. With this example, the denominator, you see, is a binomial. It's got two terms, the 2 and the -5i. So to fix it, we're going to multiply by the conjugate, which is 2 plus 5i, on both the numerator and denominator. When I do, we've got 4i times 2 is 8i. And 4i times 5i is going to be -20, because 4 times 5 is a positive 20, but the I squared changes it to a -1. Over, and here's where we're going to use that shortcut in part B of the notes above. I'm going to square the 2 to get 4, plus square the 5 to get 25. And that's going to give me a total of 8i minus 20 over 4 plus 25 is 29. But again, we want to convert that into complex form by dividing the 29 by both terms, starting with the real number first, doing the imaginary number second. So we've got -20 over 29 plus 8 over 29i. Let's do one last example. Let's do 4 minus 2i divided by 3 plus 5i. Again, I notice there's two terms in the denominator, the 3 and the 5i. So we're going to multiply by the conjugate, 3 minus 5i, on top and bottom, numerator and denominator. The numerator is going to require us to multiply it out. 4 times 3 is 12. 4 times negative 5i is negative 20i. Negative 2i times 3 is negative 6i. And negative 2 times negative 5 is positive 10. But then we have an I squared, which is going to make that into a negative 10. All over, because these are conjugates, we can square the numbers. 3 squared is 9, plus 5 squared is 25. And we can drop the I because that's all accounted for in our formula. Combining like terms in the numerator, 12 minus 10 is 2, minus 26i when we combine the i's. And I'm going to put that over. 9 plus 25 is 34. Distributing that divide by 34 through, we're going to do the real part first, the part without the I. 2 over 34 reduces to 1 over 17. Minus 26 over 34 reduces to 13 over 17. I. And we have our solution. So the way we divide complex numbers is we just have to clear the I in the denominator by either multiplying by I for a monomial or multiplying by the conjugate if we have a binomial, and simplify what's left. This same process actually works not just for i's, but also works with radicals, and that's going to be the topic of our next video.